Kia ora. Now I want to have a look at this question. Let's see what we can figure out about what's actually supposed to happen here. So at the moment, this LED is on, and when I press the switch here and hold it down, the LED goes off. Okay, when I release it, it goes back on again. Okay, so in this question in the assignment, you've got to make some changes to the code. I want to introduce you to the assessment and to the simulator. Okay, so here's the simulator. What we've got is we've got this development board. Okay, it's called an ESP32 Dev Kit 1, and it's got a number of I/O pins, input-output pins, sometimes called GPIO, general purpose input-output pins, and you can see that they've all got a number, 25, 16. In this case, the LED is connected to 12, so if I hover over the LED, it says it's coming from 12. Okay, the switch is connected to 27, and at the moment, if I hover over the switch, it says 227 because that's the pin that it's connected to. Now when I click the switch, you'll notice that the value here goes low. Okay, so that's a 1, that means high, and that means 0. Okay, so with an ESP32, these run off 3.3 volts, so that means that a 1 is 3.3 volts or high, and a 0 is 0 volts or low. Okay. Now let's just have a look at the simulator. We can move these tabs around so that you can make the screen larger or smaller, giving yourself more real estate. If you want to, you can change the layout and colours for this if you want to. Okay, and you can change the size of the font. If you keep going, it gets bigger and bigger until ultimately it resets again. So let's just set this as a standard. Okay, it's got some scroll bars on the side which sometimes play up, and I'll get around to fixing that one day, don't worry about that. Okay, over on the left here you've got all the information for this question. You'll notice there's some drop down boxes for you to fill in, choose, and there's something special about this that also has to happen. Okay, so as you go through, there's some really important concepts here: inputs and outputs. Systems have inputs and outputs. Okay, with a technological system we're talking about a device. For instance, a remote control for your television might have input buttons and an output, the output of which is usually some sort of infrared light signal which goes to the television. Same with your air conditioning unit if you've got one. Okay, so these are inputs, and this is a processing device of some description, usually a computer actually, in this case a microcontroller, which is really just a miniature computer stuck inside one little chip. Programs in this simulator just mimic what happens in a program that's running on a real-life device. There are some limitations around this, but basically I can run my program by stepping into it. And you can see that it started here. This is where the code actually starts to run. Void setup. This is the first function that is run, and this function is run once when the device is powered up. So all of your setup code goes here. So the next thing that happens is that I'm going to change pin 12. Now if I stop this, you'll notice that this says LED 1 pin. Okay, and LED 1 pin is defined up here in what we call a macro, and it is actually pin 12. So that means pin 12. So the LED is actually connected to pin 12. If the LED was connected to 13, then this number here should be 13 to say a pin. Now we don't use numbers like 12 down here, okay, because that makes it really hard to understand what is going on in a program. So we use macros, and macros are human readable definitions for things, particularly things that do not change in your program. So that could be a number which doesn't change in your program, or it could be an I/O device because that's not going to change during your program. And so this function here, pin mode, says that pin 12, which is our LED pin, is configured to be an output because we need these pins. These are general purpose pins, and they're general purpose I/O pins, which means they can be either inputs or outputs. So we need to change it to an output. We need to configure it or set it up as an output, and that's what that does. Equivalently, the switch, which of course is 27, so again I could have written 27 here, but that's not human readable or understandable. So we use a macro to say this is our switch pin, and it's an input pin, okay? And I'll describe, and you'll learn about this pull-up term a bit later. So this basically configures it to be an input, and that's what this is, and it's on pin 27. So as I step through my program, you'll see that this LED 1 pin and switch pin are actually automatically just changed to the numbers because that's what they are. So you can see that here. Now the first step of the program is to run this, and this is the runnable code. Okay, this function and this function are the runnable code. These things up here are not runnable. Okay, they're just indicators to the compiler that we're going to use these values or names. Okay, so the first thing that happens is that we configure these as outputs. Cool. And inputs. So that's the first thing that's done. And then we go into the loop. And what you'll see next is that the loop function will continue to run forever. Okay, so I'm just stepping through this using the step command. I can also at any stage just click on run, and it will run that automatically for me. And I can change the speed of that by clicking on these arrows, or of course by dragging it like this. So that way you can actually slow it right down and see what's happening line by line if you want to. Or again, you can just flick back to step. Okay, great. So let's run this. And I'm going to run it as fast as I can. I've made this, so that's actually running as fast as my browser will allow it to run. Okay, usually a microcontroller like this ESP32 will take about it'll run about 80 million instructions or lines of instructions per second. Now my browser runs JavaScript, and this is a simulator written in JavaScript in a browser. Okay, it will not run at anything near that rate, but it is doing a reasonably quick run. And what you can see is, let's just slow this down now, is that the program is running sequentially. I've slowed it down. So let's see, what is this program actually doing? First of all, it's reading the value of pin 27. Remember, if I stop the program, that pin 27 is the switch pin, and it's going to read it into memory. So if I go over here and I click on the variables tab and I run my program, right, you can see that at the moment it's going to detect that the value of the switch, right, and I could call this switch value or whatever, is a 1. Okay, but if I press on this, it will go low, and the next time it gets to this point of the program, it will change the value in the variable to 0. So I'm going to slow this down and show, because this is a really important concept about the fact that microcontrollers run in a sequential pattern. Okay, so I'm slowing it. Let's slow it right down. Now it's going to test it at this point here, and then I'm going to hold the switch down. You can now see that the switch output is 0, but the switch value has not come around to that point until there, and now it's changed. Okay, so you can see that it's sequential. It will only change the value in the variable when it actually gets to that line of the code. So I'm going to release the switch now. It's going back to 1. You can see that my value is still at 0, and that's because my program hasn't got around to line 33 yet. And there it has, it's finally got to it. So this is this concept of the fact that these controllers, all computers, run sequentially one instruction after another. Now this particular microcontroller has got 2 cores, and some of you will have multiple cores on your computers at home, which means that they can run several instructions concurrently or at the same time. But in this situation, excuse me, we're only running code one line at a time. Okay, and so you're aware that this takes a certain defined amount of time for this to happen. Now I've slowed this right down. Okay, this is going to take quite a while, so I'm going to press that switch again now, and the value of the switch goes 0, but the value in the variable does not change until it actually reads the switch input pin again. Okay, which is now. Right, so let's go back to 1. So this is a really important aspect of programming, the sequential nature of a program. Okay, so we've really got to get a grasp on this before you can go forward in your understandings. Now you'll also notice that the loop program is running continuously. And that's the nature of this. You won't see this in a normal program on a computer, okay, because that's not how they work. In a microcontroller, we need our device to be automatic, to run consistently from the moment it's powered up to the moment that it's powered down. And that's usually because we have these things inside devices like dishwashers or the brake system of your car. And we want these things to work while the power is applied to them without any human input. And we often refer to them as automata or as an automaton. Right? So that's automata and automaton are words that we might use to describe these. Automata being plural and automaton being singular. Now your purpose in this program, if I go back to the instructions, you've got to read these instructions and figure out what you've got to do and answer all these questions, right? So, but when you've answered these questions, and down here it says change the program code so that when the switch is pressed, the LED is on, and when the switch is released, the LED is off. So at the moment you can see that switch is not pressed, and it's on. So I want it to be the opposite of that. And when I press it, it goes off. So I want it to be the opposite of that, okay? Now when you've done that, what this is going to do is you're going to save your answers by clicking on the button. I'm going to save these answers now. And you'll notice that the code will be run and the input switch will be manipulated automatically by a test algorithm that I've written for this simulator. So we'll just watch that happen. Let's see, a capture is in progress. It's running the code, okay, and it's doing a number of loops. So it's on loop 5 at the moment, loop 4, okay, and at the same time it's manipulating the switch to change its value, okay, and then it will come back and tell you whether it's correct or not. So at the moment it should come back and say, hey, it is incorrect. I've got all of these answers wrong, and it's incorrect. So what you need to do is you need to actually modify the program and answer the questions. There's a bit of an introduction. Now I've also said this is a simulator, okay? It's not a complete simulator for a real device, but what it is a cut down version to help you with your learning, and that's really important, I feel, in terms of helping you understand this equipment. Now if you find that there's a bug in it, let me know. If you think there's a feature that should be implemented, let me know, and I'll try and work on those if I can, but I necessarily have other things to do as well. So I hope you get on with these questions and that the simulator proves to be a useful tool for you. In the last question of this, there's not a question, okay, but what it is a simulator for you to design with yourself, okay, and so you might want to connect a potentiometer and wire it up to this, and you can see that the code becomes automatically configured as you do this, so you can connect LEDs and wire them up. Now just in terms of wiring things, if I'm going to connect an input like a switch here, I click on the device and then I just draw with this, and it will automatically flick to a pin that it is allowed to connect to, okay? Can't connect to 3.3 volts or ground, and these pins 1 and 3 can't be used because they're part of the serial communication. But I'm going to connect that to 18, and then down here it's automatically configured this for you. And if at any time you just want to change it, you can just click on it and you can drag that to another pin, and it will automatically reconfigure this. So that there changed from 19, and here it will change to 21. So here you can design your own programs, build your own little interface here, okay? And yeah, I think that's enough information about how to use this for the moment. Cheers.